All right, guys, it's time, so let's start with our today's webinar. Good morning, everyone. My name is Deepak Sharma, and we are a group of 5 guys who started this group 10 months back, and this is our 10th tech event and second webinar. We have organized our first webinar in the month of October near Diwali, and again, since it was a festive season, we have both Christmas and New Year together turning up, so we decided to put this webinar up so that our listeners can sit back at their home, relax, and attend this tech event. So this is our second webinar, and coincidentally we have both the speakers with us named Karan. And both speakers are experienced speakers in Oracle database technology. Karan Dodwal, who is the OCM, he'll be presenting on DataGuard 12c. And this is going to be very interesting session, as Karan will walk us through various features of DataGuard in 12c and how and when to use it. Then second session will be having of Karan Kukreja. Karan Kukreja will be presenting on Oracle E-Business Suite, cloning and patching techniques. This session must be for Oracle Apps DBA as well, who work on E-Business Suite. So by not wasting our time, I'll give a very small introduction of Karan Dodwal. He's an Oracle architect with specialization in Oracle high availability environments. Karan is also Oracle Certified Master with several years of expertise on Oracle database and Oracle development. He has worked as Oracle consultant and he has given several services and training on Oracle products in Asia Pacific, Asia South, and Greater China region. Karan is also an author of OTN articles on Oracle Technology Network, and he's active speakers of this North India chapter and has presented several sessions in past on Oracle technology. He's having expert knowledge on high availability solutions like RAG, Exadata, DataGuard, and others. And pretty frequently, his articles going to be published on several websites like OTN and other along on his blogs. So Karan, I'll just hand over this webcast to you. You can start with your session. Karan, can you hear me? Karan, I can see that you're connected. Can you hear me?
Hello. Yeah, thank you, Deepak. Can you hear me?
Yeah, we can hear you.
Yeah. Thank you so much, Deepak. And good morning, everyone. Welcome to the webinar of AIOUG, Oracle Users Group, All India Oracle User Group, North India. And welcome to the webinar. And here we will be starting the webinar for Oracle 12c DataGuard. And in this webinar, we will be learning several 12c new features for Oracle DataGuard. Especially, our focus will be on FarSync instance. And I would request everyone to mute yourself so that there is no echo and everything. So thank you once again, guys, for coming to this webinar. And let's start the webinar. And I will just share my screen and let's start with the webinar, and I'll share my entire screen rather. Yep. So guys, I hope everyone can see the screen now, PPT slide. Welcome to North India chapter, the power to connect and conquer. And this is our North India chapter webinar and on Oracle 12c DataGuard. So this is 12c DataGuard, and here we will be watching live demo on FarSync instance configuration. And before that, we will be, getting, a basic overview of 12C data guard architecture, and along with that, several other features, enhancements like security features like SysTG privilege for data guard and broker, and other enhancements like DBMS rolling package to to simplify and ease the upgrade procedures, and several other features like global data services. So let us start the webinar. And about myself, Deepak has already told you about, regarding my introduction, and just a quick overview. I am OCM, over 8 years of experience with Oracle technology. I'm a speaker of North India chapter AIOUG, and I'm an author of 14 articles. And here is my social networking profiles. And you can like us on Facebook, AIOUG.NIC, North India chapter, and to hear about recent upcoming events, and other technology and new feature and other events which we keep on organizing. And you can like us on this page for getting further updates. And let's move on, guys. And of course, you can reach us on this Facebook page as well if you have any queries, or you can, write us directly on our emails or Facebook. So we are directly, reachable without any issues. So let's start, guys, with the data guard overview. This will be the agenda, of course, for our 12C data guard. First, we will understand the overview, various 12C data guard new features, understanding the parsing instance, and then we will be pushing on to the live configuration, where we will be showing you the live setup of parsing instance with three machines, the three virtual machines, and one will be primary, second will be used for parsing instance, and the third one will be a standby terminal. Let's start, guys. For your conventional architecture, this is the data guard architecture, which you guys must be, must have been familiar with. For those who are not, what basically happens is, if you see in this picture, on the left side there's a primary database, and on the right side there's a standby database. What basically happens is all the changes which are happening in the SGA of primary, the redo log buffer, all the DMLs which users are performing are synchronized with the standby. Now, if you watch here, there's a log network LNS process, log network server process, which keeps on.
Uh, Karan,
Yeah.
Karan, sorry to interrupt. This is Karan this side. We can only see the main slide as of now, the slide one. Have you moved to the slide two? Yeah, now I can see slide five.
Now you can see. What I'll do is, wait, I'll just share my whole system
Yeah, that will
to
be great.
avoid these issues. So,
Yeah,
so now you all can see.
yeah.
Okay, perfect. So,
Thanks, Karan.
yeah, yeah, yeah. So, so this is the architecture of data guard. And guys, like I was explaining, that the changes which happens in redo log buffer, all the DML changes which happen are pushed to the standby. Conventionally, it used to happen with this LNS log network server process, if you see here, synchronous and asynchronous. For your understanding, synchronous here means that the primary database will be waiting for the confirmation from at least one of the standby terminals. And once the standby terminals give the confirmation, okay, yes, the redo change has been written to the disk, or it has been received, and then the primary database can commit that particular transaction, depending on if you're using sync affirm or async no affirm for that particular log archive destination. If you see here, after an older releases like 9.9 and 10G, it has been enhanced. The performance of the data guard, the shipping of the changes. Like, for example, now log writer does not pass the redo changes to any of the processes. Rather, log network server will be pushing the changes, and later on, if there is some gap, let's say there is a network failure, or there is a lag for some other reason, maybe a disaster or some other reason, if there is a gap, so archive processes on the primary database will be resolving the gap by pinging basically the RFS. If you see here, remote file server, RFS, is on the standby. Now, for your information purpose, if you must have read Oracle documentation for 12C, There is a network server sync process, NSS. That comes into the picture where synchronous is configured, synchronous based replication. Asynchronous, like I said, means the primary database will not commit that particular transaction till the time it has been shipped and acknowledged from the standby. Asynchronous means, oh, we don't care if it is shipped or not, the primary database will continue committing the transactions. That's basically in max performance mode. So like I was saying, internally for your information, the people who are, are interested in internals, what basically happens is if there is asynchronous transmission happening, internally Oracle invokes the redo slave transport slave processes, which starts with TT, double T, then 00 till ZZ, and internally those will be shipping the changes to the remote standby terminals. And if you have synchronous configuration, sync, and then NSS, network server sync process will be, will be coming into the picture. But that's yes, this is a conventional DLNS up to 11.204, and on the destination, of course, a lot of people, have tried their hands, to apply the changes faster to the standby. If you see here, there are some apply processes in the logical standby that will be LSP, logical standby process, and in MRP, in physical standby, it will be MRP, media recovery process. And a lot of people have tried to, apply changes as fast as possible to do the recovery, to apply the changes as quick as possible in production, because we keep on having lag for some other reason, network problem, network latency issues, or some other issues, maybe like maybe the bugs. Recently we solved one of the bug, like in 10G, the host was not able to resolve, so we put in the IP address, it used to work. So for some other reason, there used to be a lag. So a lot of people have tried to, have even been succeeded by increasing the value of, parallel execution message size, and, increasing the MRP apply, recovery speed. So just for your information, from primary to standby, the more archive processes you configure on the primary, the more, the more speed of shipping the changes from primary to standby happens. For your information, maximum you can configure 30 archive processes, which are configured with log archive max processes initialization parameter, and then you can monitor them with $archive processes. And so basically, this is an architecture for your information. And and I suppose you guys are already familiar with all of these, because our focus in this webinar is FARSIC instance live configuration, along with an overview of 12c data guard features. If time will be there, we will be discussing in details. But yes, time is a factor, because it's supposed to be a 1-hour webinar, and we'll focus on FARSIC instance configuration primarily. And so let's move on to the next slide. Protection modes for your information. A quick overview. Like I said, maximum synchronous transmission also happens. You have an option for that, and that's max protection. What's max protection? By default, for your information, it's max performance. So max protection means that it will be a synchronous transmission. Primary database will be providing to all the standby terminals a zero data loss configuration, and zero data loss. That means what? A primary database will not commit the transaction on the primary database till the time it has been acknowledged by at least one of the standby terminals. And if it does not happen, let me tell you, primary database will shut down itself. And in max availability, it is as same as max protection, but the significant difference is that the primary database, if it is not able to ship a redo change to the standby, it will not shut down itself. Rather, it will convert itself to the max performance mode, that is asynchronous. And what's asynchronous? That means primary database will continue committing the transaction even though they have not been acknowledged on one of the standby, at least one of the standby terminals. Synchronous, again, max availability. We will later understand what is far sync and fast sync. Okay, and max performance, like I said, asynchronous mode, you don't have to worry about the synchronous and the network latency. If there are some issues with your network latency, it's better you configure asynchronous mode because of geographical distance. So if there are like thousands of miles away, your standby terminal, it's better you keep it on max performance. Previously, you used to do that to avoid issues of the network, and because in synchronous mode, primary database does not commit the transaction. So and you don't want that overhead, uh, if you have network issues or network latency or any other sort of issues. So that's why most of the DBAs put into max performance async mode to avoid all these issues. Now, welcome to 12c. Wouldn't it be great if we are able to use synchronous zero data loss, along with the asynchronous transfer? Well, yes, welcome to 12c. That's far sync instance. So what basically happens, if you see here in this picture, there is a primary database in New York, and there is a standby terminal, thousands of miles away from New York, typically. You can say roughly 1,000 mile, and that's London. And if you see here, there is a FarSync instance, which is geographically very near to the primary New York. And when I say near, I mean like you can say 50 miles, or maybe 100 miles, or maybe 150 miles. And what basically happens is that the primary database will quickly ship the redo change to the FarSync, so that it can use the synchronous mode. Now watch here, we are using sync here for zero data loss. Now later, FarSync instance can keep up with all the standby terminals later on, and it will be using asynchronous mode. Now the $1 million question is, what is the benefit? The benefit is are many. If you see here that the FarSync instance later will take on the responsibility to resolve the gap of all the standby terminals. In this case, there is just one standby terminal. In production, in real-time environment, depending on your data center, you might be having like 10 or 6 or 5 standby terminals, and resolving them might be an issue if it is synchronous transmission. So the idea is quickly ship the change to the FarSync instance, and later FarSync can handle the syncing and resolving the gaps with the standby terminals in asynchronous mode. Now, if you see here, if you see the word compressed here, if you have opted for advanced compression license, the compression overhead will not be taken by primary now. It will be taken by FarSync instance. So that's another benefit. So you can say primarily FarSync instance is taking all the overhead of all these things. So primary is offloaded. So isn't it great? You're saving resources here. You are offloading primary here. Okay, so there are many other benefits which we will be discussing in a while as well. So because FarSync instance, let me tell you, once it receives the redo change from primary, okay, it does not apply on FarSync itself. It just has to store the the redo change. That's it, and it will forward this change to the standby terminal, because it does not have any data file. The FarSync instance itself does not have any data file. So basically, it is a lightweight instance. It only has its standby redo log, control file, okay, control file, the password file. So it simply holds a repository of archive log and forwards it to all the standby terminals, and yes, provides you zero data loss. So one important word or sentence I would like to say, that it is providing you best data protection with minimum performance impact, isn't it? Okay, so so in other words, you can say that let's understand FarSync instance details. So, well, yes, we know that it is a lightweight instance which has only a standby control file, password file, standby redo logs, and archive logs. Remember, there is no data file because we don't apply here, and it cannot be used. Obviously, if there are no data files, you can't open it. You can't open it in read-only or read-write mode, and it's not running redo apply. So basically, like I said, it's quite near to primary to avoid long network latency for synchronous transport. And yes, 12c fast sync. Now this is an important word here, fast sync. Fast sync means here it is almost similar to FarSync. The difference is that if the geographical distance is a little more, let's say roughly 300 miles probably, Then what you can do is you can configure fast sync. That means what? It will act like sync no affirm. Now, sync no affirm means here that the network server sync process on fast sync instance will give you the confirmation that, okay, we have received the redo. But we will not get the confirmation, the primary. The primary will not get the confirmation that it has been written to disk. So that is why the word is no affirm. So, the confirmation is brought pretty quickly because of the geographical distance. We want this kind of behavior, which is sync no affirm. So that is the word fast sync, which further extends distance between primary and fast sync, because so many issues are there, so many variables are there, like for example, the redo write size, the available network bandwidth, the round trip network latency, standby IO performance. So many issues are there, and all these impose practical limitation on the distance that a standby can reside from a primary database. So, and of course, this is the new feature which we are discussing, fast sync, and this removes basically the standby IO performance from the limitations of all the list which I have just told you, and it helps us, to further extend the distance that a fast sync can reside from the primary database. This is basically, the overview of a fast sync instance, and so let's move on to the next slide, which is a fast sync instance. Let's go live. What we will do is we will now see live how to configure a fast sync instance. So what we will be doing is basically, let me give you an overview first of all before going live. Create a control file for fast sync instance from primary, and this control file we will push it to the fast sync instance. Copy the P file, let's say making changes, make the changes of all the initialization parameter, push the P file and the password file from primary to fast sync. Copy the control file, I've already explained that. Configure the standby redo log files, and to avoid this we will use log file name convert, so automatically it will be created. Start the fast sync instance in mount state, verify the configuration, and we will be verifying as well. And one important point here as well, that TNS and the listener configuration as well on the FARSec instance. If the listener is already there, we will simply do a static registration and make sure all the TNS is working fine. So let's go live, guys, quickly without wasting time, because time is an issue, of course, because there are some upcoming presentations as well. So to save time, I have already written here on the terminal, if you see here primary, what I'll do is I will open 3 terminals quickly, and uh, just to explain you the environment, first of all, we have basically prod1 is the primary. It is already configured, and then we will configure farsync fsync1. Okay, will be the farsync instance, instance, and sby1 is a standby terminal. Okay, now just to give you information about the environment, we have node7.example.com. This is serving primary, and standby node8.example.com. This is just a host name. Okay, just a host name. You should focus on the instance names, and the prod1 fsync and sby1. Basically, these are our DB unique names. fsync1 farsync, and this is on node3 dot example.com. Okay, so I hope the host names are clear to avoid confusion later on. Okay, and to avoid confusion, what I'll do is I'll now here I'm logged in on host 7, node7.example.com. That will be my primary, and prod1. Okay, so we are all set now. To save time, I've configured script already. This is my database role primary prod1 read write. Just to show you the scripts, this is the script which I'm using, and it's already been created, and you simply have to run with at role. Now, just to show you, now I'll log into the standby SSH node 8, and here standby 1. Okay, just to check what is the time here, it's 10:26, and we will just quickly select archived, applied. We will also check the sequence number as well, and if it is synced with it or not. V dollar archived log. Well, the last change happened at 9:22, and presently it is 10:27. So what we'll do is we'll simply try to switch the log file and see if this configuration is working fine, and just check, fire the
बढ़िया
query
है वो
again.
उसका क्या जम्मू का क्या स्टेटस है
Okay, so if you see here, the latest change is also received here, 10:27. So that means prod1 and sb1 is working fine, and now we will move forward to our fsync1 configuration. Uh, so the first step will be basically we will configure. Guys, can you mute yourself? I'm getting some noises, so I request you to mute yourself, everyone. Fsync1, and let's make this change in this p file. Okay, this is a primary database init.ora file. So what I'll do is I will make changes here. So this will be fsync1, and what I'll do is control for the control file. We can specify control underscore files, and we can use this directory because we will ship this control file. So we will make this directory on the destination control01.ctl. And what I'll do is now, and this is the service for the XDB, that's parsync1. And one more thing here, guys, that I'll remove the standby parameters and configure them separately so that you guys understand it clearly. Now here I will mention all the changes so that you guys can understand it quite well. So this will be the local. Now guys, remember we are configuring a P file for farsync, fsync, which is farsync. So this will be our flash recovery area. Use db recovery file dest. Okay, and this destination is valid for all roles, all roles, all log files. db unique name is fsync1. Log archive destination 2. Well, there is a typo here. Yeah, log archive destination 2 service. Now remember, like I said, primary will be shipping the redo changes to farsync, and then farsync will forward it to standby terminal. So destination 2, that will be our standby terminal. Okay, and valid for. Now I hope you understand this parameter. That means what? Ship the redo changes if the role is standby, and ship it from standby log files for this particular destination SBY1. So this is the meaning of this SBY1. Okay. Now very important parameter, file server. What is file? Fetch archive log. Now this farsync will be fetching the archive log from where? If there is a gap, it will fetch it from primary, of course, prod1. Okay, and db unique name. db unique name will be, of course, fsync1, and the service as well, fsync1. So just to make sure there is no typo here. Yeah, we are fine now. And log, it's better we can use our initially configured script here. So log archive config. Now for you guys, which the document I will be sharing with you later on, these are the changes which we will be doing on parsing. We have already done that, by the way, just for your knowledge. So to save time, I will push this log archive, log file name convert. We don't need db file name convert, remember. To save time, I'll just copy it. You don't need db file name convert because we don't have any data files on parsing, isn't it? So log file name convert it from prod1 to fsync, and in the future, maybe if sby1 becomes primary, convert it from sb1 to fsync1. Log file name convert. So guys, we are ready with a p file. Okay, now guys, just to show you, this is our 12c database. Of course, we are using 12c, and this is our 12c show con name. Okay, this is show con id. Okay, this is our, and select name, open mode from $pd ps. Okay, so this is a prod one actually, and so p file, guys, is almost ready. P file is ready, and we'll ship it to node 3 of fsync. Okay, so what else do we need? We need to push the password file as well. So I'll quickly, what I'll do is I'll ship it without wasting time. Let's ship it node 3. Ship the password file or a pw prod to node 3. The home location is same. This is the advantage of having the same location. You have no issues of directory names. And fsync1, perfect. So we will be shipping the control file as well. And before that, let us quickly configure the tns admin tns names.aura, and I'll copy it from the previous to save time, and I'll just edit this one, fsync1 and fsync1. Now watch the host name carefully. You have to be careful here. node3.example.com, fsync1. And what we can do is, guys, we can push this TNS to both the host, standby terminal, SBY1 and farsync both, isn't it? So node 3, firstly node 3, which is the farsync, shipped, and now node 8, which is the standby terminal, isn't it? Pushed it, fine, we are fine now. And the only thing which is left is to create directories and the control file. That also we'll do. Now what I'll do is I'll open a terminal, and for your reference, what I'll do is I'll name this terminal as farsync, so that you are not confused. And ssh node 3. Okay, host name. So just to set the home, there's already like maybe orcl, just to set the home, I have used it. Okay, now remember, we already shipped this p file fsync1. Okay, let's quickly make the directories. This will be for control file and standby logs, and this will be our auditing adump. This is necessary. And fine, guys, all we need to do is configure a listener over there. And one more thing here, the control file, and before the control file, we can simply say Oracle SID fsync1. Till the time it logs in, what we'll do is we'll go to farsync graphically. Okay, this is our node 3. Okay, and we can set up a listener here. This is node 3, guys. This will be hosting farsync. To save time, we can simply use either netc or netmanager. If the listener is already configured, we will register a service for farsync instance. So, well, listener, its default listener is there. So what I'll do is I'll register a service fsync1. Okay, and this is the Oracle home. Make sure the home name is correct. And finally, we can start the listener if it is not started already. Yes, it was not started. So status, and just watch the listener.aura file. Just watch here. Okay, so static registration is successful. So we are all set now. Come back to primary and create SP file from the P file which we configured. This is the location. There is an issue with a parameter typo, that is service valid for service there is a single quote in between. Service SBY1 seems to be fine now. Yep. So fine, and we'll configure. Now I come back now, guys. What I'll do is to avoid the confusion, I'll put prod1 set SQL prompt, set SQL prompt prod1. Okay, and I'll configure a farsync instance control file. Create farsync instance as u01 control01.ctl. It's already there, so let's, maybe it is some old one for another database. What we'll do is I'll write here f sync1.ctl. That sounds better, isn't it? Yeah, that sounds better. So what we'll do is, guys, we will ship this particular control file. Okay, we'll ship this control file to farsync instance, because this is the last step which is left, isn't it? So copy the location fsync1.ctl node 3. Where do we want to ship it actually? Because the parameter file says that I'm going to ship it to fsync1 control01.ctl, I guess. Yes. Yep, it's copied. So let's confirm over there by mounting the farsync instance. Well, it has been mounted. Perfect, guys. So just to confirm, the host name, guys, we are on node 3, of course. It's a remote connection which I have taken. Okay, and what I'll do is SQL prompt, and that will be fsync1. There are some changes which we have to do basically before we move on. What we will do is very important, guys. Alter system set log archive config, isn't it? All these parameter dgconfig. Dgconfig will be prod1 fsync1 sp51, isn't it? Alter system set. There's a typo. Okay, so make sure you put this parameter even on standby terminal. Set SQL prompt sby1. Okay, just for your information, guys, this is node 8. Okay, node 8. I'll change the terminal name as well. sby1. Okay, perfect. Okay, and I'll push this change here on sby1 as well. To save the time, we can use the script already, which is there. So we are almost done, guys. Nothing is left, just this parameter maybe. Yeah, this is also done. So what we can do is here, guys, very important here, file server. To save time, what I'll do is I'll simply paste this parameter. File server, this is on standby terminal, sby1. Fetch archive log server. Fetch it from where? First, I want to fetch it from farsync, isn't it? Because standby is receiving from farsync. If it is not available, okay, prod1 will be serving it. And not only this, you can configure, an alternate destination, from the primary, that okay, from primary, if redo is not able to be shipped to the farsync, an alternate destination standby one, that we can configure, because a disaster can happen, something wrong can happen on farsync as well. So if farsync destination is not available, the alternate will be the standby terminal. Okay, a very important parameter configuration change from primary. Guys, watch here. We're about to make a very important and probably the last step is this one on primary. I'll just increase the font size for your understanding. This is alter system set log archive destination 2 on prod1. Has to ship it to service fsync1 sync affirm. Watch here, sync affirm means synchronous transfer. Okay, valid for, of course, online redo log files. Okay, primary role. That means if this database is primary, and ship the archives. Okay, archive it from online log file and ship it to the fsync. Perfect. So we are almost done now. Okay, we are almost done. Just to confirm, I come back to farsync just to confirm the changes. Log archive config. Oh, this has not been changed here. Log archive config. log archive config, and yep. So we are set here, and just to make sure nothing is missing, just to make sure we are done. Even the log file name convert is done, guys. Log file name convert. Perfect. So one more thing here, that the local destination for standby. Yep, it's configured. So now let's do one thing. Now log into the FarSync instance and check the connectivity. Sorry, it will be. And this is node 3, remember. This is for what we can do is we can write here. Okay, that sounds better. This is node 3. This will be FarSync. Okay. Now let's go to the flash recovery area and see if our archive logs have been shipped. Well, till now they haven't, because maybe we have not switched log file. And guys, make sure you check all the TNS configuration before you move ahead. fsync 1, it's working, and on FarSync TNS ping, that will be fsync 1. Okay, and did we ship that TNS to the standby terminal node 8? Because that is equally very important. Yes, we have. So in a while we will be getting the archives. Okay, in a while. By that time we can check all the parameters, because it takes maybe a minute or so to sync from the primary, because there may be some pending redo logs. Before that we can check all the parameters. Log archive config, yeah, this has been configured. This is fsync. Okay, so just to check if file server is there. Yeah, it's there. So we are almost done now. Even the changes has been done on standby. So perfect. This is fsync 1. Perfect. So just to check if the listener is listening to the service, and just to check if we have copied the password file as well. Well, yes. Or a pwf sync 1, we have shipped the password file as well. Right. So yep, archive is here now, guys. So this is a good news that our configuration went perfect, literally perfect. So archive has been shipped, and though it took a little, I guess a minute or two. Okay, and let's try another log switch. Now, very important here. Very important here. Let's check the current log sequence, because verification of the current sequence, guys, is 131, isn't it? So here 130 has been received. Okay, let's go for another switch. All the system switch log file. Okay, so just watch here. Node 3 ls-ltr. Well, 131 is also received. Now watch here, host name, of course, just to make you confirmation, make a confirmation, grab smon fsync 1. Perfect, guys. Okay, and just to verify our standby terminal, if you see here, perfect. I have already configured a script, guys. If you see here on standby, remember we are on standby terminal, hostname node8.example.com. This is our standby terminal. Run the script from $archive logged, archived, applied sequence number, completion time. Now watch here. Right now the time is 10:47. Okay, and the last change was applied on 1046 and sequence number 130. Now to confirm that primary is shipping to FARSync, FARSync is forwarding to standby terminal. We need to make sure that the change has been received on standby terminal as well, not only FARSync, isn't it? To make a final verification. So switch it here, another switch, make another switch, / enter, make another switch, and come back to standby terminal. This is the one, / run the query again, 1047. So we are fine. So our configuration is a success. So we made sure the password file is copied, TNS entries are proper, listener is listening to a service, and everything went perfect. Even the parsing control file was created and pushed. Just to make sure, just to show you, this is how we create a parsing instance control file. Okay, come back to parsing. Let's verify properly. Finally, the role. This is our node 3 remote connection, just to show you hostname node 3 and role. This is parsing. Okay, so we are done, guys. Parsing. Okay, and so we are done from our side. This is a successful parsing configuration with 3 different machines. Okay, this is the parsing. Now, just to make sure that this video consists all the steps, I will show you my file, and later maybe you can pause and see all the configuration. Changes to the primary database. This is my file, a text file. So this is the changes which you make, and then later changes to the parsing instance. Changes to the parsing instance. These are the changes, and changes to the standby database. This is the changes, and last change, of course, which is needed is this one. I'll copy it. Alter database, set standby to max availability. Okay, this will provide you the zero data loss protection, and of course, sync has already been configured. Remember, by default, it is max performance. Okay, and this you will set it up in primary database. So, congratulations to all of you, and parsing instance configuration. And now we move on to the features. Let's go live part is done. Okay, let's move on. Broker new feature, guys. In 12c DataGuard, we have broker new features as well. We have a validate database command, and internally it checks automatic diagnostic repository and DataGuard views. You know what this validate database command does is, previously, before failing over or switch over, we want to check, okay, fine, are we eligible for a switchover or an unplanned failover? Okay, so because your standby terminals might be lagging behind, isn't it? So for that purpose, there is a validate database command. It tells you that whether your particular standby terminal database is eligible for a switchover or a failover, so that it does not have any errors internally. Well, resumable switchover is basically, in the past, every one of us have had failures, while doing a broker switchover or failover, because there are possibilities that there can be a network failure, there can be some other Oracle errors, okay, which are not allowing us to do a switchover or a failover. Now what we will do is, basically in 12c, we will troubleshoot the problem, okay, and when we execute a switchover, that will continue from where it left. In the previous version, I personally have a lot of issues. I personally had to delete the broker configuration and recreate it again. Delete the configuration of the broker and create it again. So that was a lot of that was time consuming, wasting a lot of time unnecessarily. So here, solve the problem, resume the switchover from where it left. So broker will resume from where it left. Isn't it? Sounds better. Sounds good. Enhancement of 12c. Transport lag configuration threshold. Transport lag. If there is a lag for a standby terminal, it will generate warning. Okay, and you can generate a threshold, write a value for the threshold. Apply lag configuration, configurable threshold. If there is an apply lag, you'll get a warning. Okay, you can configure a threshold for this one as well. That, okay, fine. If the standby terminal is lagging behind 10 minutes or probably or 5 minutes, please give me a warning. Support for cascaded standbys. For broker now in 12c supports cascaded standby as well. Just for your information, guys, cascading means that okay, primary ships to a standby or probably a far sync, and then probably a standby database terminal, let's say, forwards to another standby. This is cascading. And now you know what in 12c, a new feature is also that is cascading the standby databases. They apply, the changes in real time. Now, when I say real time, I mean that okay, in real time, the moment they received on the standby, forwarded to the cascading standby. If we do not mean real time, we mean that after the next log sequence, literally after a switchover on primary, isn't it? And support for cascaded standby is definitely there in broker data guard new feature. Other key enhancement: DML operations on global temporary table. DML operations, when you do update, insert, delete on global temporary tables, uh, in active data guard. Doesn't it sounds good, guys, that in active data guard, not only we use it for reporting purposes or ad hoc queries probably, we can do DML on global temporary table. Sounds well enough, isn't it? Why it happens internally, let me tell you. Internally, the architecture is like this: you have a new feature, temp undo enabled. Traditionally, what you do is up to 11.204, if you make any changes, okay, if you make any changes, let's say to a global temporary table, the redo is generated. Okay, the redo is generated basically, and what basically happens is, for example, is that if you perform, let's say, a salary update from $1,000 to $2,000, the old image goes to the undo table space, okay, and the redo is generated for that, isn't it? Because you understand that okay, fine, redo is not generated for the global temporary table. Then what's the benefit? The benefit is that in previous versions, the change goes to undo table space, and for undo, every redo is generated. That is an issue, isn't it, guys? So if you make a change to a respective global temporary table, and that change has an old image, the undo change, that goes to the undo table space, and whatever goes to undo and whatever undo is generated, the redo is generated for that. Now that was an overhead. The traditional redo was not an issue. The redo generated by the undo was an issue. So we have a new enhancement, temp undo enabled. If you set it to true, enable it, okay, what will happen? That old image will not go to undo table space. Rather, it will go to the temporary table space, and then no redo will be generated. No redo will be generated. That's simple. So with this temp undo enabled enhancement, global temporary table can allow you to perform DML operations. SysDG role. Now the responsibilities are separated. Data guard configuration and broker setup will be done by another privilege, SysDG privilege or role. DBMS rolling package, well, to make your work easy. To make your work easy, because traditionally when we used to do rolling upgrades, there used to be n number of steps. Oh my God, n number of steps. I have to, do a switchover 2 times. I have to, perform so many DDLs sometimes, and there used to be a lot of steps. DBMS rolling will solve your life. Will save your time and solve your so many tasks, and it will relieve you basically. So you just have to, execute just a few steps and go on with the DBMS rolling upgrade with minimum downtime. Another enhancement is that you can now move the location of online data files. You can rename them. You can rename the data files, move it from one location to another file system to ASM, and so on. Other enhancements are also there. Probably, we'll discuss them in the next session if we get a chance. Let's see what we'll bring in next time. RMAN is enhanced for data guard now. Manual synchronization for standby is made simpler in 12c, like I said. And now it's a perfect command, guys. Recover database from service name. Just give the TNS entry for either the primary, okay, or another, let's say, for example, traditionally you used to, ship, the archive logs from primary to standby, okay, or maybe ship an incremental backup from primary to standby. Well, you don't have to worry about any that anymore. Simply do recover database from the service of the primary, and you're done, okay. And so because active data guard, let me tell you, active data guard saves your life. Even it will solve the corruption for you. recently we had some corruption problems, and that was automatically resolved by Active Data Guard. Because if Active Data Guard is configured, let me tell you, in fact, you have a license. It's a specially licensed feature, Active Data Guard. If you have an Active Data Guard license, and if a block is corrupted on primary, you can get a good copy from standby automatically without manual intervention from the DBA. It sounds good, right? Because traditionally, I personally have faced, a lot of headaches with the corruptions, because sometimes if there is corruption in primary, okay, fine, go to standby, do an EXP, export, and get the table, push it back to primary. That's how we used to, solve so many corruption issues, or maybe, restore it from the backup, get a good copy of archive log, yeah, get a good copy of archive log, or probably go to the trace files internally, rebuild those, logically corrupt indexes, and so many issues were there. Just go to Active Data Guard, you will get, corruption solved automatically. Why we used to, do EXP the table from standby, push it to primary, because if you do EXP DP internally, Oracle creates some master table, and that's not supported. I mean, a standby database, you can't do DML, isn't it? Because master table requires DDL and several DMLs. So, that's how, Active Data Guard solves problem. For your information, guys, license information. Well, Active Data Guard, like I said, it's an extra cost option with Enterprise Edition. Okay, and FarSync, very, very important thing. FarSync, like we discussed in the whole presentation, you are given FarSync with Active Data Guard. So it comes with Active Data Guard. Fast Sync, which we were discussing with, which provides us, okay, sync no firm. If there is a, if there is a, like 400, let's say, or 500 miles of distance from primary to FarSync, the geographical distance is quite little more. Okay, so in that case, you can have a fast sync, which will quickly, confirm it to the primary, even though even though the redo change has not been written to the disk IO standby redo log files. However, upon receiving by the RFS process, the confirmation will be quickly given. So this saves, a little, you can say, almost a millisecond probably, if the network latency is having no issues or no glitches. And GDS, Global Data Services, is included in Active Data Guard. Okay, this is a new feature of 12c, Global Data Services. What it is basically, guys, you have been playing with services for so long now. You have real application clusters, you have Active Data Guard, you have global, you have Golden Gate. Now imagine you have a data center where you have like 50 or maybe 60 databases, in which half of them are replicated like anything. Okay, and in that complete data center, you have a replicated environment, and you have like a real application clusters working, and Golden Gate and Active Data Guard. And so what basically is GDS, Global Data Services? It basically extends, the concept of services to one step ahead. Okay, so basically internally it is a mechanism used for workload management. Okay, in the case of rack, and again to the complete globally replicated environment configuration. Okay, which can include any combination of rack, single instance, Active Data Guard, or perhaps, like I said, the Golden Gate. Okay, just for your knowledge, internally, how does it work? Now, logically, we will configure just one global service. Now, the word is global service. What we will be doing is basically, we will be, allowed to set, a preferred and available database, not an instance, for that service to be specified. Okay, and basically the available databases will support a global service. If the preferred database will fail, and not only this, the global data services will allow us to configure services to run on, on all the replicas of a given global data services pool. Now, what is a GDS pool? And probably we'll discuss it in our next session. Okay. Now, a very important point with our global data services. Now, guys, imagine, what if I say your clients will be routed to a particular replica, let's say an Active Data Guard or a Golden Gate replica, okay, which is not lagging behind the primary. For example, there are like 10 standbys. Okay, 9 of them are lagging behind, and one of them is more recent is more recent probably, and or let's say it's completely synced with the primary. Rest others are not in sync. So wouldn't it be great if I allow you to route to a replica that is not lagging behind by setting a tolerance limit, established with a lag attribute of a global service configured with the global data services. Okay, that is the advantage of global data services. I hope you got an idea what global data services is. Or not even this, we have a complete data center, let's say, and you can even define a region affinity. Affinity of region. Like for example, it will allow you, to set, a preference for a particular customer that, okay, I want to connect to an Asia region because Asia region is quite near to me. I have a network proximity which is quite near within the Asia. Because within the Asia we have a data center which has like 5 databases which are quite near to each other. So it's better I connect from database 2 to database 3, which is in, let's say, India, Bangalore to New Delhi. Okay, that's more near. Okay, because I prefer to connect to my nearest region. That is what can happen with global data services, which we just discussed. Region affinity, like I said. Okay, replication lag. Okay, tolerance limit for connecting, for routing the particular user or customers. Sounds perfect, right? So snapshot database, let's move on. Snapshot database, it only comes with enterprise edition. Snapshot standby is basically, it allows you to open the standby in read write mode, testing mode. Okay, it automatically creates a guaranteed restore point for you once you're done with your testing. Okay, or come back automatically, just fire one conversion command from the broker. Okay, you're back to your original standby. Okay, advanced compression. Okay, of course. Yeah, yeah. I mean, advanced compression for if you want to use, let's say, network compression from FarSync to the standby terminals, you would of course need advanced compression. Okay, so uh, now these are the references, guys, which I took, and just in case if I had any queries, I referred to these documents. And so guys, I hope you enjoyed the session. Thank you so much. And just let me check a review. Yes, so finally, we are done with all of our agendas quite well on time. I was afraid we might not make it on time, but yes, we literally made on time here. And I thank you. I thank every one of you who attended this webinar, and stay tuned with the North India chapter, which is our Oracle users group. And if you have any questions, just write to us, probably on Facebook or any other, the host, Mr. Deepak, okay, or anyone. Okay, so just write to any one of us if you have any questions. You can write directly to us. And relative to this particular presentation, you can find our North India page. If you see here, it's on fifth last. This is our Facebook page. And if you have any other questions, you can, technical question, you can write me as well. I'm reachable at this Gmail email ID. And thank you so much, guys, once again. And thank you so much, Deepak, for connecting me.
Thank you, Karan. That was a really informative session with, the live demo, telling the users how we can make a best use of DataGuard 12c new features.
Thanks, Deepak.
Yeah. Okay, guys, and now moving on to